Welcome everybody to this month's Third Thursday. My name is David Stevens, also known as Laser Dave. Thank you for joining me for another Third Thursday seminar. Today's seminar will be on laser processing acrylics with your laser system. Acrylics are a material that has a lot of mystery to it, a lot of tips, tricks, techniques. It's also a very common practical material that naturally works very well with laser systems. It engraves with clear edges. It engraves with it engraves with a frosty surface and cuts with clear edges. So it's a great material to work with. And so today's course is going to go through all those tips and tricks, hopefully answer your questions. We also have, of course, Alan Grizzly, he's our materials manager that will be joining me today at the end to help answer all the questions that you may have. If you do have any questions, please feel free to post them during the course, and we will take the time at the end to go through all those questions and answer them one by one to make sure all your questions are answered. So with that, let's go ahead and move into my seminar here, and let's get going. So again, today's course is laser processing onto acrylic. Acrylic, like I said, is a great material to work with. Comes in all types of shapes and sizes and material thicknesses, and it works very well with the laser, which is one thing that I really like with it. Okay. So today's course actually has QR code links. If you're not familiar with QR code links, then it's pretty simple to use. Just open up your camera app on your phone, point the QR code, but don't take a photo, and a link will show up on your screen. Select that link for quick and easy access to web links, files, and videos. I will have many of them throughout this course so that you can access some of those different resources that we will be referring to and discussing throughout the course. This course, of course, will be recorded and posted on our YouTube channel, so if you need to come back to it for reference at a later date, you're welcome to do that so that you can have access to those at a later date. Trotec is a very social company, as we've said before. So if you do want to follow us to keep up with different applications, laser materials, QR codes, please subscribe to the proper, please subscribe to your favorite social media platform. We are on Facebook, YouTube, Instagram, Pinterest, and Twitter. So today's outline is going to include a material overview of acrylics, processing techniques for engraving and cutting the material, some advanced tips and tricks, as well as some application inspiration, different types of applications that we have, we can show what has been processed with this material. So, acrylic compatibility. The one thing that you want to understand is that certain types of lasers work better with acrylics. Laser compatibility is primarily the CO2 side when it comes to lasers. There are some abilities to process acrylic with a fiber laser, but mainly like black acrylic can be turned white with a fiber laser, but that's about it. So the primary application product for processing acrylic would be on the CO2 side. And this includes our flatbed systems like our Rayjet series, our Speedy series, as well as our large format SP series laser machines. As long as it's CO2 laser, it's going to be able to engrave, it's going to be able to mark, it's going to actually be able to process into the surface of the acrylic. Some of the most common application markets that we have found for the laser industry is acrylic trophies and awards, advertising technologies, architectural model and construction, digital printing, displays, decor, dimensional letters, point of sale materials, acrylic jewelry, outdoor and indoor signage, shop and exhibition stand construction. So it is a great structural material. Works for display, decor, and the nice thing I like about it is because it comes in so many different colors and looks and feels. Unlike a lot of plastics, acrylic has a high perceived value. Most plastic tends to have a lower perceived value because it looks like plastic. Acrylic works on so many different markets and applications due to the fact that you can get that opaque look. You can get that frosted look. You can get a glitter, a mirror. There's so many different types of acrylics out there, and they have that high perception because of how they look, how they feel, how they refract the light. And so unlike most plastic, it really is a frontline type plastic that can work well. And then because it works so naturally well with the laser, it puts it into a level of basically a category of material that kind of is standalone. And this is why I've done some of my application Third Thursday seminars on just like plastics in general. This is why something like acrylic can actually afford to have its own course, because there are so many different variabilities with this material. The advantages of acrylic is it is a very popular. Acrylic is a popular manufacturing tool used in so many different industries, signages, displays, awards, and it's also a great alternative to glass due to its cost, weight, durability, and ideal processing abilities on the laser system. It's also UV resistant. Most plastics are not, and so that makes it a big advantage, allowing you to put it outdoors. Outdoor materials. And using it for outdoor applications, most plastic are not UV stable. There's a very few lot of types of plastics that are not UV stable. And acrylic is one of those materials that reacts exceptionally well to the laser when it comes to cutting, engraving, and marking, in addition to being outdoor UV stable. And it's really the only plastic out there that gives you kind of that whole the whole gear, and it gives you the good quality. It looks good as well as it can handle outdoor, indoor, and most plastics they may be able to handle outdoor are not laser friendly, like PVC or materials like polystyrene or what's the other one I'm thinking? Polyurethane type plastics. They tend to they work outside, but they will not produce the kind of quality that you see typically on acrylic. And that's really the big difference. And so because of its excellent optical properties and looks, it does give it that huge advantage. In addition to the fact that it comes in a wide range of colors, textures, and finish combinations, you can put it into so many different possibilities. Now, a few things to kind of understand as you're going through and understanding acrylic, or maybe you don't understand some of the specifics of acrylic. There are two main types of acrylic out there, only two. And it is really important to understand the difference between the two, because it can dramatically affect the finished output when you're processing with your laser system. There is cast acrylic and there is extruded acrylic. And the difference between the two can determine what it is that you're going to do with that. And so this is why I want to cover each one of these. So cast acrylic is created by pouring liquid glass between two glass plates, resulting in a homogeneous, tension-free material. It's a higher thickness tolerance than extruded. It produces a burr-free edge when laser processed. It's a better, higher contrast engraving results than extruded. Produces a milky white, almost a frosted looking engraving when you engrave cast acrylic. It is more expensive than extruded due to the production process. However, the quality on engraving is a much better quality when it comes output from processing it. Now, extruded acrylic is manufactured through extrusion process. Basically, it's like a spaghetti noodle. It's heated up and then it is extruded out of a nozzle, which actually pushes that acrylic out into sheets and forms and rods and whatever it is that you're making. It has a lower thickness tolerance than cast acrylic. Laser cutting will produce a side, basically one side of the edge is not as sharp, but kind of a rollover edge. Basically, it's got a lower melting point. Laser engraving will produce kind of a gray matte, almost opaque, non-frosted looking appearance. And I'll show you what I mean in a video on the next slide. It requires less power than cast acrylic when processed, but it's a great option for print and cut type applications, and it's less expensive. So if you're just buying acrylic, the edge quality is also usually looks very clean when cutting acrylic because it is low. I mean, one corner may not be as sharp, but it's not very noticeable. So this is a great material for running structural type stuff, print and cut type applications and stuff like that. So, but you really need to keep an eye on what acrylic you have to know what you're going to get from it. If you're planning on seeing a frosty white effect, then the quality you may suffer based on the difference. And here's an example. So if I were to play an example of what cast acrylic looks like, you can see it produces a frosty white, really nice high contrast mark onto the clear acrylic. Where if I were to play an extruded acrylic at the same power settings on the same machine, as you can see here, it produces an opaque, transparent, kind of a ghostly looking image when it comes to processing it. So it is not the best material when it comes to engraving. And this is the big difference between the two materials. Cutting, you know, extruded may be a little bit more melty, but your edges still look really good. So cutting extruded is outstanding. Cutting cast acrylic is outstanding. The difference is mainly when it comes to engraving it. So if you engrave a piece of acrylic and it looks like the extruded acrylic, there's not a lot you can do. Now, if you're planning on paint filling it, it's going to work just fine. If you're planning on just cutting it, or maybe if you're doing print and cut type applications where you want to print on the acrylic and then use the laser to cut that out. Another good solution because it is a lot less costly than the cast acrylic. Now, Trotec manufactures all different types of cast acrylics and types of acrylics for you. And this is because of the modern innovation of variations of acrylic, of making it with so many different looks and feels. It really allows a lot of diversity when it comes to different types of applications, looks, feels. And so we produce a clear, your standard clear cast acrylic, which is going to be, you know, in multiple different thicknesses, but we also do multiple colors. Frosted acrylic. Troglass LED is another great one, which allows LED lights to transmit that light through the acrylic at a much greater rate. So if you were to place a standard off-the-shelf piece of generic acrylic onto a piece of, or an acrylic light strip, it's going to light up. But the Troglass acrylic LED is going to light up much brighter. It allows that light, those light photons, to go through the acrylic at a much higher rate, and we get a much brighter response. Troglass Reverse is a plastic that is basically coated on one side. So when you remove engraving on the one side, you can see it through it. It's great for doing signage, paint fills, back paints. Satin materials is like a more of a like a softer frosted effect. The Troglass Duo, all different types of colors of acrylics, the metallics, the glitter. So basically what this does is it allows for diversity. If you're doing point of sale materials, if you're doing flashy gift items and stuff like that, it gives you a lot of diversity to make that finished product really pop and look good for you. The ADA signage materials and the Trolaze materials, we also offers different materials can be combined with it. They are also an acrylic-based material. Signage material like your plastics that engrave into them are also made as one of the primaries out of acrylic. And so these are going to allow you that two-tone or contrast material. Great for signage, great for displays, and you can adhere two different layers or two different colors together. Again, UV stable, which is the benefit of acrylic. Also the Troglass mirror. It's a clear extruded acrylic with a mirrored layer, perfect for artistic, decorative items. The nice thing is when you etch into a mirror on the front or the back, and a lot of people don't realize you can etch the front side of a mirror with a laser. Lasers don't reflect off of common like acrylic mirror or glass mirror because the reflective surface is basically paint on the backside of glass or acrylic. And so you can do some very interesting effects. You can etch away the back coating of the mirror, paint fill it to produce contrast, and then you can flip it over and actually engrave on the front side as well, which is going to give you kind of that extruded looking frosty effect on the surface as well to give you a two-toned effect. So you can have a lot of fun with this material. It looks like a mirror, it looks like glass, but it's also cuttable because it's made out of acrylic. And that's a big difference. You can't cut glass, but you can cut acrylic mirror. And so it is a great material to work with that because you can produce very artistic, decorative, and creative applications. Now, most acrylics and the film plastics that are acrylic-based tend to have protective masks on them. And I get a lot of questions on this. You know, should I remove it? What kind of mask? Especially when you go to an off-the-shelf acrylic manufacturer, maybe you buy it at your local hardware store. The question comes to me all the time: is the protective mask that is on it something I should keep on when I cut it, when I engrave it, when I mark it? And that really depends on the mask itself. Some masks you can definitely leave it on and then cut it in place. Other masks can actually cause flare-ups and damage if you leave it in place. And it really depends also. Are you engraving through it to paint fill it and then use it as a mask to do that? Or are you just leaving it in place to cut it out to kind of keep that acrylic from being scratched over time? The Trotec, of course, acrylic has a very special paper mask, protective mask over the surface to prevent scratching and other damage during handling. But it can be left on, of course, when laser processing for certain cutting applications to provide better results. And that mask can be left on until the product is assembled or given to the customer. In some cases, it's left on all the way to the point where the customer actually removes it so that that finished product is brand new looking when it's peeled off. And that is the benefit of the masks. And so the difference, though, is you want to make sure your mask is left on if it can handle it. And so some brands, some types, some off-market types of acrylics, the masks can be a problem. They're made of some types of papers. They also can be much thicker than materials. If you cut them, they can actually lead to the possibility of a flare-up. And it's not the acrylic that's causing the flare-up. It's the paper mask that is doing that. So my suggestion on masks, if you're not familiar with it, run a small test. Keep close eye on the machine. And if it does flare a lot, maybe remove the mask on just the front side when you're cutting and leave it on the back side to maybe protect it. And then when you're finished, place another mask on it. If the mask does not work and you get a lot of flare up from it, my suggestion would be to peel it off and then place maybe like a transfer tape mask, your own version of mask over it, which will protect it and also not be flammable. This has been a problem on some off-brand, non-Trotec brand or off-the-shelf, inexpensive acrylics because those masks are just designed to kind of protect acrylic. They're not necessarily great to work with the laser. So Trotec uses a plastic mask, and that mask offers a lot of advantages over the paper mask, one being that flare-up I just referred to, because the paper mask has that basically combustive agent into it, which kind of sends it over the difference of being able to cut through without a flare-up versus not. The plastic masks work very well. All Troglass products come with plastic masking. Masks, paper or plastic, should be removed during the engraving process in some cases. It depends on what you're doing. The only time I'll ever leave mask on when I'm engraving it is when I am possibly going to paint fill it. Because if you engrave through the mask, put a little depth into the acrylic, and then you paint down inside the engraving, and then you peel that mask off, it's going to give you that subsurface color-filled process. The problem is you're engraving that residue from the mask in addition to can it handle paint, for example? So you got to be careful with that in those cases. So always run tests for it. So, but in most cases, masks should be removed during the engraving process. If you're planning on just doing a light, kind of a frosty look into the surface of the acrylic, then you will always want to remove it because even no matter how thin that mask is, it will not look as good. And it'll also potentially melt into the acrylic and it won't look as good. Unless you're engraving a lot of depth into it, you always want to remove that mask before you start engraving, at least on the top side. The back side, that's going to be put against the cutting table. You can leave that in place, even if you're going to cut it afterwards to kind of keep it from being scratched. But definitely on the top side that you're going to engrave, I would always suggest removing that mask for light engraving. The other big issue, and really the main concern with acrylic, is flammability. This is a material that is, it's very flammable. Because it works so well and flame cuts so nicely, a lot of people want to really cut it slow to get that nice flame polished edge. Well, in order to get that flame polished edge, especially cutting thicker materials, you have to run very slow. And when you run very slow with a high temperature heat source like a laser, combined with a highly combustible material, you run a much higher risk for flammability. So this is a material you want to keep a very close eye on. It is an extremely flammable material if left on monitors and if flames occurred. And I've had customers say, I've never had a problem. I did it for years. I never really paid much attention. But over time, you can also get buildup of residues in your cutting tables. Your lenses may not be as clean, and that is typically when it happens. So this is a material, you don't have to be as vigilant when you're etching something like brick or stone by any means, because it's not a flammable material. If you're cutting acrylic, you need to watch this material like a hawk. Never keep your eyes off of it. Always stay in the room when processing, mainly, of course, when cutting the materials. Because of that, it is one of those materials that work outstanding with a laser, but it can go awry very quickly if not kept up with. Kept close attention to. So always keep close eye on your cutting when cutting acrylic because of that. Even myself, I've been doing this 20 years. I'm always in the room, and I've had 2 or 3 close calls over 20 years. Fortunately, I've always been right there, but had I not been, it could have gotten bad very quickly. So next, let's go through some different processing techniques on how to process acrylics. Acrylic has, works so well with the laser, but there are a lot of techniques that I can teach you that you may not know that is going to improve your processing of your acrylics better than maybe even what you do right now. So cutting acrylic is one of the first one. The one thing is you want to make sure your laser has the correct wattage for the thickness. And you always want to cut in one pass. Yes, the laser can go multiple passes to get through thicker materials. But you will find when you cut a piece of acrylic and you go low and slow until you get through that acrylic, your quality is always going to be better. So cutting in one pass, no matter how thick. And if you have too thick of acrylic and the only way you can get through it is multiple passes, you're going to really reduce your quality. In addition to, your best bet is to make sure you have enough wattage to cut that acrylic. The higher the wattage, of course, the thicker you can cut in one pass and give a nice edge quality. The next one is, of course, you want to focus into the material a little bit, and you want to use the right lens. The right lens for the acrylic, depending on which type of lens, which we're going to get into a little bit on how to kind of make sure you use the right lens with the right acrylic. Most acrylics, depending on thickness, your standard 2.5 inch lens are going to be fine for cutting. But as you get up thicker and thicker, there is some variabilities, which we'll get into. Make sure you're using adequate speeds and frequency settings. Always run tests. Never assume. There are a lot of different types of acrylics out there. There are a lot of different thicknesses of acrylics out there, different lenses, configuration. So always run a quick test. I always run like a little square with a circle inside of it, or a square with rounded corners, because you always want a radius and you want a square corner. So, and this will tell the laser, this will give you a good example of exactly how to how that acrylic is going to perform. And then do a small little, 20 millimeter, 1 inch type block and just cut it out and take a look at it. Make sure it's nice and straight. Make sure the edge quality is flame polished and smooth looking. Make sure your power and speed and frequency settings are correct. That you got good airflow. You're not getting a flare up before you attempt to run your large finished product. Proper airflow is huge because of the possible flare up. So a proper airflow using a good exhaust system. And then in addition to using the appropriate cutting grid and table, which we'll get into as well coming up here. So cutting power is basically, there's kind of a rule of thumb here that allow about 10 watts of laser power for every 40 thousandths or 1 millimeter of material. So as you increase in thickness, this is kind of a simple math problem. You can identify what wattage do I need to produce a productive effect. When it comes to high production, of course, the more wattage you have, and if you're just cutting all the time, the faster you're going to be able to produce. Even up the high wattages on these smaller flatbed machines, 60, 80, 120. I've done 200, 400 watts. It never is enough. You're never actually able to run at the full speed of your laser machine. It doesn't seem to matter how much wattage you have. So the more power you have, definitely the faster you're going to be able to produce the finished product. In addition, you're going to be able to get that nice flame polished edge on the thicker materials because you're going to be able to get through. It builds up more heat and you get a much better finished result. As I said before, passes. When cutting acrylic, it is always recommended to cut with one pass. Cutting with multiple passes, you'll actually see where you've started one pass on the edge, where you started the second or third. It literally looks like steps into the cutting edge. So be very, very careful when processing acrylic, making sure that you go low and slow. Always move your power to 100% power and then drop your speed. You want to keep your frequency pretty high, typically between 2,000 and 5,000 kilohertz, or in order to to get the frequency higher. Higher frequencies like higher pulse rate. So think of a frequency like a sewing machine. As you take it up higher, you get more stitches. And so the laser fires more times. More laser pulses means more heat. More heat means a more flame polished edge. And so running a low frequency or a low PPI, depending on the brand of laser you have, you'll actually see little striations or a little like lines down your acrylic. And so higher frequency is recommended in order to get that flame polished edge quality by increasing the amount of heat so that laser fires more times as it's covering that distance. In addition to making sure it's done in one pass and your power and speed settings are correct, the big one too is making sure your lens is set correctly. The thicker the acrylic, longer focal lengths can make a difference because of the convergence. As you can see here, the convergence and divergence of a lens. It's not like the sci-fi movies. Unfortunately, laser lenses converge. It's more like a magnifying glass. You know, if you've ever taken a magnifying glass in the sun and kind of moved it around until you get the smallest spot size so you can burn leaves, for example, as you move it in and out, that beam becomes much larger. Laser beams work the same way. And so as you go in and out of focus, the beam basically becomes larger, whether you're in focus away or farther away. You get more of an hourglass shape. And so that hourglass shape can actually transmit itself into the edge cutting. So if you focus right on the surface of the acrylic, you're going to get more of an angle cut. So when you cut it out, really thick material using a shorter lens, and you go to set that acrylic on the edge on thicker stuff, you're going to see it sits at a slight angle. So to do that, what we'll do is we'll focus into the material a little bit. We'll actually focus the laser slightly into the material. And so defocusing into the acrylic, so going towards the acrylic, so that basically you get that, and I'll hit back here, you can get that divergence kind of some set into the acrylic. And what that's going to do is give you a straighter cut. Longer focal lengths actually have a longer hourglass shape. And so your edges can be, you're not going to see as much angle. The flip side, or the drawback of longer lenses, is your beam is larger. And because it's larger, it takes more laser power to process or cut. And so longer ones are going to give you a straighter edge quality. However, it's going to require more power. So you have to slow it down more. And so there's kind of a cross between how slow do I want to go to get that good edge quality versus how straight do I want to cut it. And so that can be a difference. And there's kind of a rule of thumb that when you focus into it, anything thicker than 1/4 of an inch, 3 millimeter, I typically start focusing into the material slight. So I would go into, say, 1/4 inch material like 60,000ths of an inch, which is about 0.06. This is going to kind of allow that focus point of the beam to be more centered into the surface of the acrylic. And when you cut your finished product out, it's going to be straighter. But another drawback of this is because you are focusing into it, your beam is larger and you're going to have more kerf loss. Kerf loss is the size of the channel that the laser cut. So if you are cutting something on acrylic that is tolerance based, so you're going to measure it on both sides, by focusing into it, you actually have a larger swath from the laser beam itself. And what this happens is, so your product is actually slightly smaller, maybe straighter, but it may be slightly smaller. And so you may need to compensate for that if there is a tolerance issue. Here's some kind of rules of thumb when it comes to speed. And to achieve that kind of flame polished edge, the lower the speed, the more heat can build up, in addition to the frequency, which I mentioned earlier. Maximum power, and I put maximum frequency on here. You don't have to go maximum frequency. You basically want to find a frequency that's going to be that's going to give you that flame polish, but it also depends on the thickness that you're running. So for example, here's some settings that I used on my 360 80 watt running 6 millimeter or 1/4 inch acrylic, 10 millimeter or basically 3/8, 1/2 inch, and 3/4 inch acrylic, 100 power. And as you can see, the speed goes slower and slower and slower. And so this can dramatically affect time depending on the wattage that you have, but your edge quality will be outstanding at these settings. That doesn't mean these settings are the exact right setting. It depends on what you want and how good that edge quality. I typically go for that mere flame polished glorious looking edge. If you just need to get through the acrylic, you may be able to run much faster. And a faster means that you penetrate through, but your edge quality is not as good. So if that edge is not going to be seen, or it's not going to be seen up close, and you're just going through to get through, then definitely run a test to make sure the acrylic is that you're able to get through, and then that's it. So you don't need to worry about it as much. And so power is definitely relative to quality. Now, frequency, like I say, is a lot of variabilities on there. Basically, it depends on the type of acrylic. Around 5,000 hertz for cutting extruded acrylic, 10 to 20,000, which is basically your number of pulse for cutting your cast acrylic. Cast acrylic has basically a higher melting point, and so higher frequency is going to give you a nicer flame polished edge. Extruded acrylic has a lower melting point, so it doesn't require as much pulsing in order to get that flame polished edge. So you can actually vary the edge quality by adjusting frequency. And the nice thing about frequency is it does not affect the overall time of the finished cut, because it's just determining how often that laser fires within the same distance. So for example, if you're cutting 1 inch of cutting location, the level of frequency will determine how many times that laser fires in that inch. Higher your frequency, the more pulses. And that's really the difference is, and when you're doing this. And as you increase that frequency, you increase the amount of heat buildup in the material. And that's what's the difference is. What we're ultimately looking for is a clean, polished edge. We don't want to go too high to cause potential fire, but we also don't want to go too low to get those little lines that you're going to find in the acrylic. It's kind of a formula that you need to practice with, because it also depends on your power and speed. I typically always run at 100% power, but the speed will also dramatically affect, because if you're going too fast, it doesn't matter what frequency you use, you may not get that edge quality. So speed and frequency are the two things that you want to control the most for maintaining quality when it comes to cutting acrylic. Now, just because you get a good edge quality and your edge looks like a mirror edge doesn't necessarily mean you don't need to still try to control that excess heat. And that's what we're doing with airflow. Airflow is a method to try to control the excess fumes and heat and get them out of the way so that they don't ignite. And air assist is one of those tools that you need to do that. If you're cutting thick acrylic and you do not have air assist, I would not do that at all. It can dramatically increase the risk of a flare-up by not having air assist. So air assist is an absolute must when cutting acrylic when doing this. This will allow the acrylic enough time to cool down and result in that glass slice edge. The air assist is going to basically blow air down onto it, and it's going to cool it. It's going to pull the combustible debris that are coming out of it, kind of push them out of the way quickly, allow the exhaust to kind of take them away before they have reduce the chance of them to ignite. Too high of air assist can also be a problem. If you want a really high pressure and you just tend to have a lot of flare-ups, and so let's increase the pressure of my air. The problem with that is what happens is it injects little micro bubbles into it, producing a milky edge. When you look under a microscope of a laser cut edge, and you'll notice little it looks kind of frosty, and you wonder why that's the case. Typically under a microscope, you'll see little bubbles that are actually cooled into the surface of the edge cut acrylic. This means you're using too high of air pressure. And so there's definitely a balance here. How much laser power you have, what frequency and power you're having, and then also what air pressure you're using. Different nozzles can make a difference. The more narrow the nozzle, the higher the pressure of the air. If you manually adjust the air pressure up, maybe you have your own compressor, this can also make a difference as well. Another suggestion, which I don't have on here, is that you take your air assist compressor and replace it with a tank of nitrogen. Nitrogen is nice because it, in place of air assist, instead of just pressing high pressure air, you can put nitrogen in place, run at much lower PSI, and nitrogen displaces oxygen. So a very, very small amount of nitrogen dramatically reduces the chance of flare up, and it doesn't require a high pressure because it's not injecting oxygen into that cut area. I don't really show that because it does require a little bit more setup and additional cost. A nitrogen tank can be $300 or $400, and then it can cost you $20, $30 to refill. Nitrogen generators that you generated the air can be, $5,000 to $10,000. So it's not as a practical. Now, if you're doing a lot of acrylic, you tend to have a lot of flare-ups. No other method has really worked for you. It may be a viable solution. But in those cases, I would suggest talking to us, and we will help you kind of go about doing that. But if you're doing it just once in a while, the standard air assist, making sure it's not too high, too high a pressure, will also produce a very, very nice effect, pending you're not cutting too thick of acrylic. Also, airflow from your exhaust can make a big difference as well. So cutting off any portion of your unused bed to create more of a vacuum. If you're familiar with Trotec machines, the exhaust kind of goes down through the cutting grid. And that cutting grid, if you cover up with paper or tape or some other material that basically blocks the exhaust, and then place your acrylic over that location of the cutting table, all the exhaust is going to be pulled through that one spot. And this dramatically increases airflow, reducing the chance of flare-up. And this can actually pull the air through the cut in addition to the air assist, producing a cleaner effect, because you get the push effect from the air and the pull effect from the exhaust pulling through, producing a much clearer edge. So here is an example of, the same material in time. So this is an example of an 80-watt in-time lapse of all 5 different thicknesses cutting at the same time. They are time-lapsed at a little bit different rates of speed, but the real difference here is you can kind of get an idea on this 5-inch by 5-inch, pretty intricate cutout gear shape, what the difference of quality looks like combined with the amount of time that it takes for this wattage. So what I did is I found the best possible setting, and then I went ahead and cut all 5 different shapes of the gear here, and then put a time next to it just to kind of show you the difference in productivity when cutting some complex graphic like this. So something like an 1/8 of an inch acrylic on an 80-watt, I'm able to cut the entire gear out in 30 seconds. As the material doubles, the amount of time can go up by over 3 times. So it's an exponential time curve. And that's what I wanted to show with this slide, is that as you go up, just because you're double the thickness doesn't necessarily mean it's only going to take twice as much time to cut. It may take considerably more than that. So for example, the 30 seconds on 1/8, where it's 1 minute and 40 seconds on 1/4. And then we go up to 3/8 inch material, it's over 5 minutes. But when we get up into the really thick material, especially with something as low wattage as an 80-watt, which is pushing it to its absolute limit, I'm not going to be able to do any thicker than this. 3/4 of an inch took over 15 minutes to cut out this same shape. And this is because I needed to run it so slow that dwell time in order to cut through this is able to do that. And I wouldn't probably go any more than that. Even this is not real practical to spend, over an hour to cut 4 of these out. Not a real practical application. But really the difference, as you can see, the edge quality isn't bad. You get that flame polished edge across the board, but there is a dramatic improvement or exponential curve when it comes to the amount of time to cut different thicknesses based on your wattage. Now, if I have a much higher wattage, of course, this time will variation, but that same linear curve of how much times to cut based on thickness is going to be pretty consistent based on whatever thickness that you have. Flare-ups are not uncommon, of course. I've talked about this many times, and I kind of talked about the gasket. You can, I know a lot of people that have actually just kind of hooked nitrogen into their system itself, but nitrogen is nice because, like I said, it really does reduce the chance of flare-up because it displaces oxygen entirely. No oxygen, no flame. And that's really what it comes down to. The biggest issue that I've had with nitrogen is that it's expensive, especially if you go to like a welding supply house and pick up a tank. You also have to put a regulator on it. Then you have to hook it into your system. Now, the standard machine does not have an intake. You can buy a laser system with a gas assist feature. Basically, the gas kit is what we call it. And this allows you to actually identify pressure and actually bring in different types of gas into your laser. And this is only for those of you folks out there that are really dramatically looking to cut acrylic almost exclusively. And this is where something like this may be beneficial to you. Proper exhaust, in addition to having a good cutting table, which we're going to get into and stuff like that, is huge. Really good exhaust system will dramatically reduce the amount of flare-ups that you're going to have. So if you have an external exhaust that's got really good airflow, you're going to have a lot less issues with flare-ups. Good exhaust, if you're using a filter unit like an Atmos, you want to make sure you just choose the right style of Atmos so you have a good enough airflow to ventilate it properly when doing this, so that you don't result in those vapors catching fire. Cutting tables for cutting acrylic. We have a lot of different options, especially for cutting acrylic. Because acrylic is so popular, we actually have a cutting table specifically for cutting acrylic. So if you're looking to do a lot of cutting of acrylic and you just have a standard aluminum cutting grid, the drawback of an aluminum cutting grid is if you place your acrylic directly onto aluminum cutting grids, when you cut through it, you're going to get little reflection points on the backside of your acrylic when cutting that. And there's a couple ways around that. One is using a different type of cutting table, like an acrylic cutting grid table. This is actually a polymer-based plastic cutting grid. It is a consumable, so as you cut into it, it's going to actually cut partially into the cutting grid, and then you can flip it over and then eventually replace it. But it doesn't allow the reflection to happen, so you don't get those reflections on the backside of your acrylic cutting. Now, a aluminum slat cutting table also will give you reflection points, but the slat cutting tables are nice because you can take the slats out and only basically place them underneath the locations of maybe the acrylic you're not going to be cutting, or only in the locations because they're individual slats. Now, if you are cutting larger products and you want to be able to take the slats and put them in, the nice thing about the acrylic slat cutting table is you can replace the slats with your own laser by making more slats if you want. Or you can buy them through us in bolts and then snap them in as you're running it. And again, they are a consumable. These acrylic cutting grid table and the acrylic slat cutting table is mainly designed for cutting thin acrylics. High-speed cutting thin acrylics. It's difficult to elevate it. You don't want the reflection point on the back. The reason we don't suggest running thick acrylic with these is because you got a lot more excess heat. And we don't want that heat to not only ignite your thick acrylic, but also the table underneath of it. So these are primarily used for cutting thin acrylics, high speed, and you just really don't want that reflective on the backside. If you're doing like point of purchase displays or acrylics that's going to be lit up, for example. And when you light an acrylic up, those little edge tick marks that were reflection points that you see from aluminum really show up, and that can be a problem. And so these are some of the different options that are beneficial. And the slat cutting table is ideal, for cutting thicker acrylics because it is actually allows you to kind of move the slats around and move them into the position where you want them, and they can pop out in and out just by pulling them in and out as needed. The cutting grid table is, again, it sits on top, consumable. It's great for cutting your thinner, smaller parts, quick and easy if you want to keep those reflection points from happening, if you're going to light up the acrylic. And also you don't want your parts kind of falling down underneath because the big slat ones, if you're cutting thin or small pieces, they kind of fall down between the slats. That excess laser power could potentially hit it from another cut, so that could be a problem. Then the thinner cutting grid can make that difference. And so those are really the different types of table choices. It depends on what laser you have, will depend on whether these are an option for you. Some of these tables only work on our 360 and our 400 series machines, depending on what model you have. You can go to our website if you want to know what table works for what laser machine, depending on what you have. Now, cutting thick acrylic, I do not recommend cutting on the acrylic cutting slat table or the grid table as well. And so a thick acrylic, there's a lot of individual technique to it, and that's why I want to cover this specific. When you're cutting on an acrylic with a paper mask, it is recommended to remove the mask at least on the top side. A lot of times I will remove it on both sides because when I'm cutting very thick acrylic, that paper mask, or even in the case of a plastic mask, increases the risk of a flare-up. The acrylic slat cutting table is ideal because you can kind of place it on each side, a wider effect. Again, do not use the acrylic cutting grid table for thick acrylics because of the risk of high flammability on those materials, only for the thinner materials. And so the difference too is, how do you keep that flare up from happening? This has been something I have worked on for years. It's always been an issue. I have a laser hack that I have finally kind of found a method that works extremely well for cutting very, very thick acrylic. And so what happens when you cut a thick acrylic and you get a flare up, even on the back side that's kind of contained and the exhaust is pulled out, when you pull the piece out, it's going to look like this. And if I left the mask on, you can see the grid marks from the back side here onto the mask. And once I peeled the mask off on the mirror side here, you can actually see it's still scorched and damaged the surface of the acrylic. I may not have had a flare up, it may not have been damaging to the laser, but it truly damaged the finished product, making it non-usable. And that's the difference here. So what I have found is a simple solution for this, just by using common everyday paper towels. This is a simple process. Get my video to play here. There it goes. Basically using 3 to 4 layers of paper towels and then wetting them down. What this is going to do, the main issue when it comes to processing acrylic is, how do we reduce the heat? And so if I cover all my cutting grid up and I place 3 or 4 layers of paper towels onto my cutting grid, and then I place the thick piece of acrylic onto the surface of the paper towels over the cutting grid, and then go ahead and cut it out. What this is going to do is dramatically reduce the heat on the back side. And that reduction of heat is going to give me a much finished, cleaner result, because that paper towel actually absorbs that excess heat. No excess heat can be hit on the back side. It also reduces the amount of reflection points. Too high a wattage, I can actually elevate it using a simple little T-block here. I cut this out on acrylic, place them down into the cutting grid, and then place my paper towel underneath of it. And in this case, you can then place the piece of acrylic over the top of that. And then we can, of course, cut the same piece out as well. If you get any reflection points through the material, and the benefit of this and why this works, you can really see here in this close-up, is as the laser's cutting through, the excess energy is hitting the wet paper. That wet paper is combusting, turning to steam. That steam is encapsulating all the particles that are flammable and keeping the possibility of them igniting from happening. And this works exceptionally well. In my lab cases, over 2 years of testing this, I've never once had a flare-up, but mainly in small cases. I mean, I wouldn't typically use this if I'm cutting high production across the entire field, because the paper towel will dry out over time and it may not work as well. So this process works very well for, you want to be able to cut those small dimensional letters, but it works well enough to where even elevated for 3/4 of an inch, and as you saw before, this took 15 to 20 minutes to cut this thickness of material, I still get no flare up when it comes to that. That steam is injected underneath. It keeps my cut from igniting whatsoever. And when I'm shooting these videos too, I'm in a class 4 environment. So the lid is up and I don't have as much exhaust. And so it works that well. We're able to get that nice thick cut. We're able to get it through it. We virtually eliminate, in my case, I've entirely eliminated any chance of flame. Again, you always want to keep close eye. But as you can see here, even after I'm all finished cutting that thickness, the excess energy still didn't even cut through that paper towel. So it's absorbing or capturing all that extra energy. And that extra energy is the main reason and cause for flare-ups. So this is a great laser hack for reducing the chance of a type of flare-up on acrylic. And I've had this one online for a while, but I wanted to showcase it again within the actual acrylic seminar today, because it is so important to reduce that finished result. Or reduce the chance of flare-up, I should say. Okay, there we go. Okay, now we've done a lot on cutting. Cutting is probably the most popular when it comes to acrylic because it does give you that flame polish. But there's also engraving. Engraving cast acrylic is an easy process that requires little material preparation. less is more when it comes to it. You don't want to engrave too much power. Too much power can actually cause some problems. It doesn't look as good. So you basically want to lightly etch into the surface of the acrylic, producing a light scratched or a whitish affected image. The only drawback with engraving cast acrylic is there's no contrast. So it's white on clear. So the only way you get the contrast is by placing it in front of something else, like a dark, table or a wall or something like that, unless it's a painted or a colored acrylic. So that is kind of the only drawback. It is clear, but it does produce that stunning looking finished result. It engraves beautifully. You can do photographic quality on it, images, logos, graphics, gradients, photographs. There's really no limitations to acrylic because it can handle very, very great detail. In addition, it can also handle depth. Depth to produce nice high quality contrast. Unlike most plastics, which tend to melt and distort, acrylic, because it can handle more effect, it actually gives us that kind of three-dimensional effect. And this is great if you're creating that molded look into a surface of the acrylic. There is some techniques on this. After I've done engraving it, I will actually take it out of focus and run a second pass over the top, or a third pass, or just a black box over the top of it, out of focus by 1/2 of an inch away from the material. So what you can do with the laser is basically heat flame it or glaze it. And this is really cool when you got a frosted effect and you want to glaze it. Take it out of focus, go over that area again, and it turns it kind of that opaque, translucent, transparent glaze effect onto the surface of the acrylic. So it's a great material. You can handle a lot of detail into it. Great for photograph. It can handle depth. Of course, the edge quality can be cut, and that's why we're spending a lot of time on it today. Now, if you do want the contrast, you can also, of course, engrave reverse acrylic. And this is great, too, because if you mirror your graphic before you engrave it and then look through it, that frosted effect is on the back side and it comes through. And it adds that shiny, reflective look. Really handles lighting really good. If you cast like a red LED through it, you always want to mirror it from the backside because it just looks better, because it's not that matte frosted effect. It's got that glossy glazed effect because you're looking through the the glossy portion, and then you're seeing the cast acrylic that's been etched from the backside. So always play around with maybe mirroring your graphic if you want to see it from the backside in order to kind of get that effect. And then, of course, if you're trying to engrave, say, the difference between cast acrylic and extruded acrylic, there are some times where casted acrylic needs to produce a white effect, but you only have an extruded acrylic. And a way that you can get a more contrast, if you will, when it comes to doing extruded acrylic is take your graphic from 100% black and switch it to 60, 70, 80% grayscale. So what that's going to do is it's going to turn it to a halftone or a dither pattern. And the laser is going to pulse that little pattern. And as you can see here on the image below here, the dither pattern makes it look more frosted. So you can effectively get a higher contrast frosty look into extruded acrylic just by technique. If I do it just black, you can see it's almost that transparent, translucent looking watermark look. Where if I take that same exact graphic, convert it to 70% grayscale, hit start again with order dithering or one of my dither modes turned on, the laser is going to spread the pulses apart and you're going to get a frostier look. Your edge won't look as sharp because you are doing a halftone or a dither pattern onto it. But for larger engravings and stuff like that, you can add a black outline around it to make the edges look a little sharper. But it will allow you a higher contrast onto materials like extruded acrylic. However, in all cases, I typically recommend, if you can avoid it, just avoid etching onto extruded acrylic and mainly use it for cutting or printing and then cutting. Now, here's an example of a common reverse engraved. So in this case, it's engraved on one side and then the laser actually just etches away. These are those three-dimensional lamps. You see them a lot online where it produces a three-dimensional looking lined graphic, and then you engrave it all over the material, wipe it off, and then when you place it on a light base, that is going to give you that three-dimensional looking effect into the surface. It is a great type application, very profitable, very popular application when it comes to processing. This is highly recommended using the cast acrylic and ideally the LED acrylic because it allows that light to transmit through it at a much greater rate. Here's another example of kind of a multi-process. Here's a case where I'm going to cut out this small little fish. And what we're going to do in this case, if I can get my video to go here, is we're going to engrave textured three-dimensional graphic into this case. And that three-dimensional graphic, for some reason my video is... There we go. That three-dimensional graphic, when using relief mode, is going to allow me to actually place texture into the surface of the acrylic. And this is a cast acrylic, so it's going to frosty white. Now, when you engrave depth into cast acrylic, you see that frosty white residue. If I were to go over and engrave again, it's actually going to heat it up and actually damage or kind of melt it back in. So I will typically open it up, lightly brush it, make sure your product's in a template, blow off any excess residue. And in this case, I'm going to take and glaze a different portion of it. So the black portion of this little fish here is going to be engraved into the surface of the acrylic. For some reason, my video keeps stalling here. Sorry about this. So as the black portion is actually engraving into it out of focus, what's happening is, because I'm away from the material by at least a ½ an inch, and what's happening is it's now glazing that graphic into it. And so I get that opaque, transparent looking image into the surface of the acrylic. And so effectively, I'm doing a reverse effect. I'm using the laser to put depth into it and frosted. Then I'm going out of focus and I'm going to engrave the graphic out of focus with a glaze effect. And so this allows me to kind of showcase how you're able to cut acrylic. And so I cut it in advance on purpose, because when you cut it, I don't want it to damage or distort anything. So I cut it first. And then I produce the depth, and then which produces the frost as well. And then I went out of focus with my second graphic, and then I placed that onto it out of focus to give the glaze. So this is a kind of an advanced trait to really show you what you can do with this material. Great material to work with, because it does give us that multiple methods to produce some very exciting, fun, unique, different looking finished results. Sorry about this. There we go. Okay, so let's go through some troubleshooting slide. A few things here. No contrast. The problem is cast acrylic is not producing any contrast, resulting in a clear engraving. So maybe you do have cast acrylic, and when you engrave it, it just doesn't look right. This is typically caused by the laser being out of focus. In focus laser will give you that nice frosty effect. Make sure you can double check. That is probably one of the biggest questions I will get when they're cutting it. They know it's cast acrylic. They went to engrave it, and it is engraving clear. Like the fish I just showed you, out of focus will engrave clear. So be careful that it is in focus in order to do that. And then, of course, you want to adjust your power settings and speed settings for processing it and making sure that it is in focus. Another few advanced tips is to use dish soap onto the surface of the acrylic itself. Dish soap is a nice material for kind of protecting the surface of the acrylic itself. And it kind of adds that extra layer. For some reason, I'm having issues with my videos today. There it goes. And so what it does is that basically, if you don't want to mask it, for example, but you do want to produce depth, but you want to protect that surface from any hazing or residue that tends to form onto the surface of the acrylic, what you can do is you can place a little common everyday dish soap over the surface of it. So in this case, I'm engraving with some depth, not a lot of depth like the 3D, but just enough depth to where I'm producing a lot of like that residue. I want an actual physical small amount of texture into it. Well, when you do this, unlike the fish where I engraved the whole thing, it didn't matter. Where I want the surface to be still clear, but I need the engravings to produce depth. But I didn't want to mask it and pick off all the individual pieces of, say, paper mask. And so by doing the soap, I'm able to get a much cleaner effect, because the dish soap actually produces a layer that protects it. Without it, the heat that comes out of it can actually cause a staining or distortion on the surface, which you can see here. And this is actual damage into the surface of the polymer itself, and it cannot be removed with chemicals, with cleaning agents, with any other method itself. It's actually distorted the surface of the acrylic. And so normally you'd have to mask it. But the soap, what it does is it adds a very thin, invisible, flame retardant barrier to the surface and protects the surface of the acrylic while you're engraving that depth and produces a much nicer, clean finished result. Protecting the surface of that. So if you do want to produce a little depth, you still want that clear surface into the material, it is a great laser hack. It's placed just a little bit of dish soap over the top. Doesn't matter what brand of dish soap. I've used all types, but it works very well for making sure that haze and residue is not formed on the surface of the material. The next is cleaning. Stay away from alcohol-based cleaners. When it comes to acrylic, if you were to clean them with alcohol, and I don't care if this is like the Trollay's plastics or the cast acrylic, extruded acrylic, anything with acrylic in it, if you clean it with alcohol or if you paint it with alcohol-based paints, you're going to see little micro fractures start to form on the edge. And the more you try to clean it off, the worse they're going to get. Stay away from them. Any type of alcohol can actually produce a dramatic reaction into the surface of that cut acrylic. And it seems to kind of get into the fissures from the laser cutting process. You may clean your acrylic with alcohol all the time on the surface and it doesn't have a problem. But once you laser cut it or engrave it and you try to clean it, you're going to have all kinds of issues with that. What I do suggest is to stick with a petroleum-based cleaner like hexanes. Hexanes are a great material. You can see the difference after one day, one to the next here. The quality is much, much better. Hexanes are basically a petroleum-based cleaner. Hexanes work good. Heptane is another one. And even in a pinch, it smells, but lighter fluid works just as well. These are materials that are petroleum-based. They come from the derivative of petroleum, which is what acrylic is made out of. That's why they work so well. They're not that expensive like the hexanes here from McMaster Cars, like $29, but they do charge a hazardous material fee charge, which is almost twice the price, unfortunately. And so sometimes it is more expensive to get them because of the transport fee than the actual material. Heptane, Heptanes, or heptanes do not have that, but they're a little more expensive. But lighter fluid, of course, will work, but it tends to smell because it produces the fumes, where the heptane and hexanes do not. Here's a QR code if you want to scan it to get this material. Just stay away from anything acrylic. Because I had a customer once, they were doing license plates out of the mirrored acrylic. They were reverse engraving them and then paint filling them. And they kept wondering, customers were coming back saying down inside the paint, there's little fractures all over when you look close. This is because they were using alcohol-based paint, spray paint. So when you flipped it around and looked at it from the front side, you got those little fractures that started to form into it. Once he switched to an acrylic-based paint, the problem went away. So stay away from alcohol-based, any type of cleaners or paints when it comes to processing or trying to clean or color fill your acrylics. Preparation tips. Here's a great little tip here. If you're cutting intricate cutouts, for example, acrylic can be a troublesome when it comes to cutting out something very, very intricate. So if I'm cutting out a piece of acrylic that is got very, very close pieces together and I want the little webbing between it, if I were to try to cut that out, the drawback when cutting acrylic is it builds up heat as you're cutting. And the way to get around this, if I wanted to cut something out with lots of little thin lines in between it, is to use multiple colors and then rotate through the colors. The reason is the laser's going to cut in order of color. And so you can use up to 16 colors in the Trotec color chart. And then you can basically put all those colors at the same power and speed and frequency setting. And then you can place those different colors in different locations on your cutout. So the laser in this case is going to cut all the red first, and then it's going to go down and it's going to cut the blue next, and then it's going to cut the magenta, it's going to cut the green, it's going to do it in order of color. But what this is going to do is it's going to separate your cuts so that it allows time for that area to cool. And then after it's cool, it comes back and cuts the next one in that area. So this is going to reduce the chance of thin acrylic from distorting when you're trying to cut intricate little detail into that acrylic. So if you get a lot of distortion into your cut acrylic and you're having a lot of difficulty, just separate it with multiple colors, and then those multiple colors can allow that area to cool in between that. I've even gone to the point where I don't have a lot of cut parts. I've used a sacrifice color. So I've used a color that it just goes to a different part of the field and doesn't actually cut on anything, but it cuts really slow, allows for it to cool down, and then it goes back to the third color, back to the acrylic. Now it's given it enough time to cool down to then cut that one. So you can get crazy with it, but use color for doing this, and it's going to allow you to cut much, much thinner kerfs, and you're going to be able to get those little webbings and parts that don't distort when you go to try to cut them. You can do kerf cuts as well on acrylic. The little reflective or the little living hinges on the acrylic, I've done some really neat effects into it. Works really well. You don't want to get them too close together because acrylic is brittle, and so you want to kind of find that spacing, but it is flexible enough where you can actually do hinges and bending effects into the surface when you are cutting this material. But it's a great little application, and it really adds that perception of value when you produce products like this. When you do want to do these type of curved cuts, I do suggest about a distance of about 1 millimeter or 0.04 inches apart on the cutting distance, because you will it'll still give you reflection or I'm sorry, flexibility without actually causing the material to burn or cause damage to the acrylic, or actually cause it to be to break afterwards. And so you need the flexibility with of course, to make it still durable enough and strong enough to be able to be flexed over time. Here's a little QR code if you do want to play around with some of these flex hinges. These are right on our website. So they give you the kind of the starter, the little hinged effect. You can duplicate them across to use them on your different projects, and then incorporate them into your graphics. If you want this little box, this is a great little box project using our acrylic. I've actually engraved the frosted acrylic with the floral pattern around the sides with a clear kind of frosted floral effect. And then I used the satin acrylic on the top side to give a two-tone box, engraved both on them, plus the hinges. Produces a great effect. This is a great little project. Scan this QR code if you want to download it and give it a try on your machine. Another one is bending. Acrylic is very popular. There are some methods to use the laser to bend the acrylic, but it is difficult, tedious, and can risk basically flare up and fire. So I suggest if you do want to cut acrylic out and with your laser and then bend it afterwards, is just to go purchase an inexpensive bender. Basically, it's a heating element where you set the acrylic over that area, and then as soon as turn the heater on, and then once it's warmed up enough, you can then bend it around like a curved object. And so you can make those three-dimensional objects. And so a bender, you can scan this QR code. You can buy a bender. You can go onto Amazon. You can buy these at a lot of different locations. A lot of acrylic houses that sell acrylic also sell benders. But all they are is a heating element. They work very, very quickly. You take your shape that you cut out of your acrylic that is designed to be bent, place it over to the area of the bend, and then form it around it. I do suggest using a box or something to form so you get that nice straight edge. But the laser and a bender work really well together because you can cut the shape out with the laser, assuming it's going to be bent into a shape, place it over the heating elements where you want it to bend that down, let it sit for 5-10 seconds, and it'll harden, and then you can do the next component. And then so you're turning a two-dimensional laser cut product into a three-dimensional finished product or part. Another troubleshooting area with acrylic is excessive odor. Acrylic is one of those materials that look good. It is an outstanding, works with the laser, but man, does it smell. If you've ever processed a lot of acrylic, I do suggest that make sure that your room is very ventilated. Also, make sure that you take the finished products and you place them in a well-ventilated area after you pull them into out of the laser machine. Some people will say, well, the laser's not filtering or it's not ventilating properly. No, the problem is your finished products outgas for upwards of 48 hours after you pull them out of your laser machine, and that's where a lot of the smell comes from. I will place them outside. I will place them in a ventilated hood. The other thing is the trash that you pull out, the little pieces and parts that you don't need go into your trash next to your machine. Well, that's irradiating fumes. Those fumes can be, they really can smell. So make sure that you ventilate properly. Close your trash can. I used to have in my lab, I had a little exhaust that was actually hooked to my trash can, and I kept a lid on it, so it constantly kept a vacuum into it. And so that's something you can do. But yeah, just make sure you understand that acrylic is going to outgas for a couple days, and it's eventually going to go away. If some acrylics tend to be a little sticky on the edge, that will also go away in that same amount of time. Typically takes a couple days for that smell to go away. There's really no chemical. There's nothing you can really do to eliminate it. It's just try to avoid it by keeping yourself in well-ventilated areas, keeping the finished products as well as the components that you cut from the laser in well-ventilated areas as well. But you can have a lot of fun with it. Like I said, acrylic is a great material. Photos, reverse paint filled, color fills, signage, dimensional signs, boxes, light ups, glitter material. It's a great material to work with. I suggest you play around with it. Trotec, of course, sells lots of different types, as we discussed earlier. All your different colors and types. You can scan this QR code. We are, of course, running a promotion on acrylic this month. So if you want to take advantage of that, I will show you that here in a minute. Frosted acrylics, satins acrylics, large variety of different types of looks, finishes, degrees, transparencies. We even have acrylic that looks like glass, that looks like the jade-looking glass that is outstanding for certain applications. So take a look at our website and go through it and take a look at all the different varieties that you can actually look with and work with your laser system for processing all your fun and exciting applications. Couple updates on the month here. $100 online for Troglass acrylics. You get $25 if you purchase up to $100 or more with June promo code June-promo-2021. You can see the voucher code there in the upper left-hand corner here. And so definitely take advantage of that if you want to take and look at some of the Trotec Trobrand acrylics. It's going to give you more diversity in your product line if you're not doing that. If you missed last month's Third Thursday, you can definitely scan this QR code. We did personalized gifts. This was a great one if you're looking to start into a personalized gifts applications, or if you're looking to start a business, if you're looking to expand your business, if you're looking to see what tips, tricks, and trends that are popular in the gift industry. I covered all of that. It was great because I went through and found and contacted the different places around the world and found what products were really hot right now, what were popular right now, what were profitable right now. So definitely worth the time to spend the hour to watch that seminar and go through and educate yourself on this marketplace. Maybe give you a few ideas on how to make your current business a little bit more productive and profitable. Okay, we are all finished here. I'm now going to be joined by Alan, and Alan and I will answer all of your questions. Welcome, Alan. Thank you for joining me.
Hello, everybody. Good morning, good afternoon. Bienvenue.
All right. Well, thank you so much for sticking around with me, everyone. We're now going to go ahead and we're gonna answer your questions here, and maybe give you some of those answers to the questions that you may have had. So let's get going here. Good morning. I'm looking to cut Lexan. It melts itself back together. Would be increasing air pressure. Air pressure be an option to improve the cutting. Lexan, unfortunately, is not acrylic. Lexan is polycarbonate, and polycarbonate is a carbon-based, polymer-based plastic. There's not a lot you can do with Lexan. It is. I suggest if you are cutting Lexan that you mask both sides, and then the edge quality is just going to be charry, sooty, and there's not much you can do with that. Unfortunately, unlike acrylic where you get that flame polished edge, Lexan is not that type of material. So there's not a lot you can do with that. Air assist is recommended. Nitrogen will definitely help by reducing that amount of char, but it is a material that is not very laser friendly when it comes to cut quality and edge quality. So my suggestion is to avoid it, but if you have to do it, use nitrogen, mask both sides, and then only cut thinner materials. Alan, have you run across nitrogen much?
Actually, I did have a customer that was doing, they had an application where they were cutting ABS hinges all day long, every day. And they used a nitrogen system. And it worked really well up until the point when their nitrogen valve froze. And then then they burned the laser to the ground.
Oh, wow. That's not a scenario I would recommend. Yeah. Polycarbonate is material.
Yeah. Something to keep in mind if you do have a nitrogen system is any gas passing through a valve cools down, and you have to basically plan for that too, you know.
Got it. Yeah, good advice. Okay, what's our next question here? Is there a difference between clear acrylic and Troglass? That's a good one for you, Alan.
Yes, there isn't really a difference between our clear Troglass and the clear acrylic that you find out there from other manufacturers. Our Troglass clear is all cast, so it's going to turn white and have the really nice glossy edges like Dave was talking about. But in our Troglass line, we also have a whole bunch of other colors and finishes and reverse materials and things like that that you don't find in a plexiglass or a Acrylic or any of the other brands of acrylic that you might run into. And we have the laserable plastic mask, which is not really common out there.
All right. Excellent. Next questions. We've had problems with polymask fusing so tightly to the acrylic, it makes it very hard to remove. Is there a way to reduce the difficulty in removing it? Alan, is this something you've come across? I mean, I've only done this on some off-brand stuff, but most of the time, the masks typically, if they do fuse to the surface of the acrylics, I suggest don't use them. There's not really any way that you can get around that. My suggestion is remove them first. If you have to have mask on it, apply like a transfer tape or a transfer tape mask over it afterwards or before you actually process it, and then use your own mask. I don't know any way to reduce that sticking effect on some brands. That's the benefit of a Trobrand type acrylics. That doesn't happen.
Yeah, you usually run into that with the blue plastic mask that you find on some of the acrylics out there, especially the extruded acrylics. And what's typically happening is you're melting both the acrylic and the mask, and they're basically melting together.
Yeah.
And so, like Dave says, replace it with a thin paper mask, like a transfer tape. The trick with the dish soap would probably work better. And then the last thing is, if you are removing the mask, sometimes an eraser or a little piece of rubber, and you can the little I can't remember what they actually call them. We used to call them finger condoms, but the little rubber tips you put on your fingers when you're doing paper, accountants use those. Those work really well for getting the masking started if you're having problems.
Oh, that's a good idea. Those are the ones, it's people that tend to lick their fingers. They don't want to, they use the little rubber fingertips. Yeah, I know what you're talking about. Good idea. All right, next question. We prefer a matte finished edge on our light guides. What would be address how to make it very consistent? A matte finished like laser cut edge. I don't think you can really get a matte edge when it comes to laser cutting. The only way I've been able to get a matte edge on cutting acrylic is to inject air into it, and that's usually what we're trying to avoid. But I don't know any way to actually produce a consistent matte edge when cutting acrylic, at least with a laser, without going to a mechanical means of cutting. Alan, you come across anything like this?
No, I saw that question come up earlier, and I was thinking about it. And no, if it's a complex shape and you can do it mechanically, the mechanical engraving is going to give you not necessarily a matte edge, but a opaque or like a clouded edge.
Yeah.
The other thing you can do, if it's not a really complicated shape, is just a very fine sanding block, like 400 or 600 grit sandpaper, and you do that on the edge, and that'll basically do the same thing. It'll frost that edge up. That's
a good point. The other one I was just thinking about as well is if it's masked on both sides already from the cutting process, is to put it into an inexpensive sandblaster. So after you're done, just hit it with a real light sand, especially if you got a lot of intricate little details and cutouts. Just a light sandblaster. You can pick one up for $200-300 on Amazon, including an enclosure. Hook it to your compressor and then hit it with a light sandblaster. This way, you'll be able to get a very consistent frosty edge and be able to control it. So that would be my best suggestion. Or just try to cut it mechanically. Now, if laser can cut it to give you the detail, which can't be done mechanically, the sandblaster may be your best choice.
Yeah, that makes sense.
How do you reduce air assist for cutting on a Speedy 300? Great question. In the back left side of your arm, so if you look at your laser system, you have the arm going across that carries your little carriage back and forth. On the back side of that arm, there's a little knob behind it on the left side looking into the front of the machine. You can actually turn that knob towards the negative side, and it's going to reduce your air pressure. A lot of people don't even realize that it's back there, but it will allow you to adjust your air pressure. Now, if you're creating your own air assist through like your own compressor, of course, you can control it manually through your own regulator as well. But if you want to actually control it out the laser machine, you can turn that little knob. Note that it's not just a partial turn. You can rotate it many times. And so keep reducing it down until you get the amount of pressure that you want, and leave it at that. But be careful not to do too low of air pressure. One concern too is if you run a cone with no air pressure going through it, can actually damage your optics because it builds up heat inside instead of blowing air through it, and it can actually pull debris in and damage it. Too low air pressure can do that as well. So you always want to make sure air is blowing through your cone or nozzle if you're using it. And if you're using low air pressure, you want to make sure you have enough to where it doesn't still build up heat and allow debris to be pulled into that because of the inversion of temperature. So, but that's how you adjust it, as well as kind of, you know, your do's and don'ts. Can you laser cut polycarbonate? Yeah, I kind of answered that on the first one. Polycarbonate is a material, then yes, it can be laser cut, but your edge is going to look black. It's going to look like sooty, awful. Nitrogen is kind of the key. You get more of a yellow effect from it. Stay away from thick cutting polycarbonate. Mask both sides, high air assist or nitrogen. And then understand your edge is never going to look like acrylic. It will not be flame polished. It's going to look like basically like a gritty alligator skin looking carbon buildup on the side. If you go back and look at our seminar, laser processing plastics, I have a whole segment I showcase how to do polycarbonate. It's on our YouTube channel under Trotec Laser USA right now, and you can see examples, the do's and the don'ts, and exactly how to process on polycarbonate. My Amadeus Plus is allowing acrylic and wood smells to escape into the room. The filter meter reads 25% for both types. Any suggestion? My suggestion in this case is to stir your carbon. The carbon over time, a lot of people don't realize that kind of becomes kind of stuck down and tamped down over time. So if you go to our YouTube channel and look at our video on how to change it, actually, I'm the one that created that video on how to change out your filters. Go down to your carbon, put some glasses on, put a mask on, and then take your hand and just stir your carbon around. Basically, it's going to allow the pores of the carbon to absorb more of that smell. The other thing you want to do is make sure that you pack your carbon very tight into all four corners into your box. Because if it's not tight into those corners, it's going to allow that smell to escape past. Now, carbon is only going to remove 99 point something % of smell. The humans can smell much, much greater than that. So you may still see smell just a small amount, but if it's excessive, then I do suggest you take your box filter out, take your pre-filter out, take your carbon, stir it around. One, you're going to get a much greater airflow. It's going to prolong the life of your filters. Two, it's going to reduce the amount of smell because you're stirring it back up and allowing that carbon to absorb more smell. Anything to add there, Alan?
I would just add the other things that you said earlier when you were talking about the smell, and that you know, before you get too excited about it being your filter not working, make sure that you're, you know, moving the finished pieces and the scrap pieces out to somewhere where it's ventilated, and it's not actually just the outgassing of those finished cuts that's causing the smells. It's actually the filter that's the problem.
Yeah, and I've had so many people say it's the filter, and then once they remove the scraps and the finished cutouts, most of that problem goes away. So yeah, make sure you check both. How do you prevent laser line marks? Laser line marks. I think that he refers to reflection points on the backside. My suggestion, if it is reflection points, which is where the laser actually produces a basically a reflection off your cutting table when cutting acrylic. There's a couple ways you can use the different cutting grids that I showed you, or you can elevate it. Remember when I showed you the little T blocks on how to elevate acrylic over the top? I have a laser hack on our YouTube channel. If you want to watch it, go to my laser hack section and watch that. Basically, and I'll give you the file. It gives you the file on how to do that. It allows you to actually kind of elevate your acrylic over an existing cutting grid and give you a perfectly clean, no reflection points on the back. If you mean something different on your definition of laser lines, please note again here, and we'll explore it further.
If you mean the raster lines from the laser traveling back and forth left and right, and you see the little ridges in the back, one way you can, lines from the laser when you zoom into the surface.
Okay.
One way you can solve that is to run out of focus a little bit. The more out of focus you are, the more those lines will spread together. If you're working with acrylic, you have to be aware that that will have the effect of making the acrylic go more clear, so you'll get less contrast. The other way to do it is to do the other trick that Dave mentioned, where you use 70% gray instead of solid black. And you can use that on any plastic material. It works great on glass as well to reduce the heat and the spalling. And basically what you're doing is you're replacing those raster lines with a grayscale pattern that looks super consistent, and it gives you a much nicer finish. And it will solve that problem for you. Just change your artwork from solid black to 70% gray and run it in a dithered grayscale mode.
Yeah, and then my suggestion too, when you do that, if the edges aren't sharp because you're seeing the dither mode, is to add a black outline around it. So a very thin black outline will keep your edges sharp. I just actually produced a laser hack on doing that with glass. Same thing. But yeah, out of focus, as Alan said. The other thing is you can run a little bit higher DPI. So if you're running at 333, maybe run it at 500. May take a little bit more time, but your quality is going to go up, and the amount of lines are going to be reduced by doing that. I'm working with black anodized aluminum, having trouble with bright white. I've seen this possible. What are the general settings? Correct. A little off topic for acrylic, but anodized aluminum, if you saw it, that's really bright white. Most likely it's done on a fiber laser. Fiber lasers produce that brilliantly bright white effect. A CO2 laser don't typically produce as bright of white. Also, the type and brand of acrylic can make brand of aluminum can make a big difference. So how long that anodization process has been in the electroplating process will determine what the finished result is. So higher quality anodization will produce a brighter white on the engraving for the CO2 side, but only up to a point. If you want to get it much, much brighter, you may need to go to a fiber laser. Fiber laser will always give you the brightest white that you can get on aluminum. And then even a step further, you can go to a MOPA fiber laser, which is a special type of fiber, which will take it even to that next step, to the super bright white. So if you've seen it engraved, it could have been because of the different types of lasers, could have been the type of anodization, or even the type of fiber laser that was used. So that's why you see it at so much variation in the industry.
One of the other things with the anodized is there's a lot of garbage anodized out there. So that would be one thing, is try a different brand. The DuraBlack anodized aluminum, it's technically not just anodized, but DuraBlack will give you a whiter look usually. And then the other issue with anodized aluminum is the more out of focus you are, the less white the engraving will be. So if you're having trouble with it, don't trust your autofocus or your manual focus gauge. What I would suggest is just engrave a box, and as you're engraving, if your machine will allow you to adjust the focus while you watch it. And what you'll see is there'll be like a bright flare that follows the laser as it goes across. Find where that flare is the biggest, where you're getting the tallest flare, and that will be the optimal focus for anodized aluminum for your machine, and that'll give you the whitest mark. And then just make yourself a little gauge so that you can reproduce that focal length.
Oh,
down the
you
road.
just adjust your focus tool for it. Yeah.
Yep.
It's funny is they actually anodized aluminum is what's used to calibrate a focus tool because
Exactly.
of that little flare. So that's it's ideal for that. But Alan is absolutely right. Focus is key. Type of laser is key. Type of material is key. There's a lot of variabilities on it, as you have found. It sounds like. Look us up. We can help you out a little bit more if you need more information on this. Will the soap trick work on other plastics such as Trolleys? Absolutely. Anytime you get a lot of haze and residue on the surface, it's difficult to clean off or may damage or distort the surface of it. The soap trick works really well. Most of the time I use it on acrylic because it's that frosty or it's that, that glazed polished look, and too much heat can actually scorch the surface. But I have used the soap trick on many different types of plastics. It is a great laser hack for any plastics that you may want to put a little depth into. You don't want to mask, and you want to be able to get a lot of that detail and protect that surface. So give it a shot. Can't hurt anything. Now, just because it does protect, certainly, it doesn't necessarily mean it's going to protect for all too much power. So sometimes also another trick that I would suggest is hit it with more than one pass. So instead of hitting for a little depth, instead of hitting it low and slow, hit it with 2 passes at twice the speed. So you're not building up as much heat, and that heat's not going to damage the surface, maybe in combination with the soap. So another trick to reduce amount of haze or heat damage on the surface of any polymer.
Yeah.
Why are most of the product sizes not a full 12-inch wide? I'll let you answer this one, Alan.
It's actually funny because we get as many people complaining that the sheets, when we cut them to quarters, are too big. They're more than 12 inches. But you're right. The Trobe glass materials are typically not a full 12-inch, and they're not a full 24-inch. The reason for that is simply because most acrylic sheet is actually metric sized. And so they don't start like, for example, when you buy 1/4-inch acrylic, you're almost never buying 1/4-inch acrylic. You're buying 0.220-inch acrylic or 6 millimeters, which everybody calls quarter because it's the closest standard size to it. But the real basic answer is because our sheets start 600 millimeters by 1200 millimeters, which when you convert that to English is about 23 and 5/8 by 47 and a half or something like that. So when we cut them down to quarters, instead of cutting exactly 12, exactly 12, exactly 12, and then somebody gets a piece that's, 11 inches, we do to quarters. So that's why they're undersized.
And if you look on our website, it states that because they're not 12 by 24, they're 600 by 300 millimeters.
Yeah.
Because most polymers and most plastics are made for the globe, and we sell all over the planet. And we're the only country, unfortunately, that uses the imperial unit. Most countries do not, and so this kind of allows both an industry standard globally. That's the big difference. What's the best way to cut the acrylic grids for your jet? Trying to understand what he means by that. Way to cut out the acrylic grids for our Rayjet. You may need to elaborate on that. I'm not sure what you mean by acrylic grids. So if you could let us kind of elaborate on what you mean by acrylic grids, and we'd be definitely happy to help you, but because I'm not sure what your question is here. When lasering black on gold, I cannot get the black color. It seems to always be grayish. Can you tell me how to get it darker? I've tried out of focus, at speed. Yeah, this is a common issue because when you're engraving into as we just saw, when you engrave into acrylic, it tends to frost. And even when you engrave into extruded acrylic, you get a little bit of frosting. And so even though you're engraving into a two-toned plastic that's one color into another, you're not getting the pure black. The only way you're going to get a pure black is if you glaze it or take it out of focus afterwards and heat distort it to kind of bring that black out. It's not that it's not black or it's not exactly black. It's actually causing a little bit of a frosted effect, just like any polymer tends to do. So it doesn't give you the true black. Taking it out of focus with the second pass, kind of like I showed you with the fish, where I took it way out of focus after I was done engraving it and then glazed over the top of it. That'll really bring the black to it. I have another laser hack on our YouTube channel where you use coconut oil afterwards, and it's going to dramatically darken it, and it really kind of stays that way afterwards. It's a great trick for that as well. So go to our Trotec Laser USA YouTube channel and watch that. Simple little rub of coconut oil down inside dramatically reduces the black, and it's mainly because of the slight distortion of the polymer. It is black, but we're distorting it with the laser, and there's only so much response. The reason it's black on the backside because it was molded that way. The laser doesn't create a mold. It frosts it very, very slightly, and so you're going to get a derivative of gray. Alan may have a little bit more on this as well.
Yeah, well, there's a couple of quick things. One is make sure that it's actually a laserable product. Sometimes people either accidentally order the rotary material, or they have both and they grab the wrong sheet. If it's an ABS product, it will definitely laser gray versus the acrylic. The other thing is, don't try to engrave it too deep. The gold foil on the top of the material is 1/1000th of an inch thick. When you've lasered it, if you can feel the engraving, you're probably too deep. It's that thin. Yeah. And so the deeper you try to go, the more heat you're putting in, the more residue you're creating. And so you will tend to get a grayer image when you try to go too deep as well. So that would be the other thing. What I usually tell people to do is, regardless of what the settings are in their control, I can't remember the name of the software. I don't use it every day. Job control software.
Database. Yeah, database
or the materials database PDF, if you've got that. Regardless of what those settings are, if you want to really fine tune it, I would just keep your speed the same, reduce your power by 5% until you get to the point where you're not getting through the gold, and then go 5% more. And that's the setting you want to be. With engraving the Trolace materials, you always want to be for the absolute best results, best color. You want to be right on that hairy edge of whether it's engraved at all or not. And that'll give you the best results. The deeper you try to go, the more trouble you're going to have with surface marking and color of the background and all of the heat that you put in and the warping. So you want to really try to minimize the power that you have to use to do the engraving, and that'll help.
Yeah, one other thing I just thought of too is the type of cone, and we highly suggest on our website and everywhere else is to use the wide mouth cone. The wide mouth cone, when engraving the two-tone plastics, keep the air assist coming down, but it reduces the amount of injected air, cooling it faster and causing more problems. And I find they get a much smoother, much darker response when using the wide mouth cone with the two-tone polymer materials like the Trolace plastics than with the standard cone. So switch your cone out and use some of these other tricks we just told you about, and you're going to get a much better result.
Dave, cover your ears for a second. It engraves better without the air assist. Air assist off for engraving the laminates, and air assist on for cutting the laminates. That will work better.
Yeah, and I don't need my ears shut. I shut air assist off all the time. Make sure if you do shut air assist off, take your cone off. Don't leave it in place. It can actually damage your lens. And so if you're not going to use it, if you're just engraving, yeah, that's fine not to use air assist. But if you do want to use it and cutting, then use your wide mouth cone. Okay, next question. What's the best type of paint? What paint is best for paint filling? I assume for acrylic. I mean, it really doesn't matter. I don't care what kind of paint you use, as long as it's not alcohol based. When it comes to paint filling, acrylics at least, alcohol based paint will cause the fracturing and painting. I like to use acrylic based paints on acrylic. I get the best result. But it depends on if I want like a polymer effect, I'll use a metallic rub and buff. I'll use oil-based art paints. There's no wrong type of paint. It depends on the effect that you want. However, just stay away from any type of paints that have a base of a base of alcohol when it comes to painting acrylics. Now, any other material, it doesn't matter. Use whatever paint works best for you on other materials. But on acrylic, since that's what we're covering today, just stay away from acrylic-based paint, or use acrylic-based paints, and stay away from alcohol-based paints. Any other paint works just fine, depending on the effect you want.
Yeah, I always just use the acrylic, the water-based acrylic craft paint that you can buy at any hobby store, any hardware store for stenciling. It's available everywhere. It's cheap. It's 2-ounce bottles, so you're not investing $50 per color.
Yeah, right.
And that's always worked well for me on the plastics. You won't have to worry about any of the problems with the crazing on the acrylics if you stick to that water base, and it cleans up so easy. It's really, really simple to use.
And they actually make water-based spray paints too. So you go in there and you actually look for it. I know Ace sold it, but it actually is water-based. So if you click that, if you want to spray paint out of a can, just stick with the water-based ones, not the acrylic, or I'm sorry, alcohol-based is what I keep trying to think of.
You can also, if you want to spray it, you can also use the Preval sprayers that everybody uses for Surmark. They work just as well on those water-based paints. Yeah,
little aftermarket sprayer. Yeah, that works too. Can latex be used for creating a mask on material? I can't see why not. Latex is kind of expensive, so I mean, I wouldn't usually use that to create a mask. I would also take some time to dry, but it would work just fine for it. The thicker you place it onto it, the longer it's going to take if you're trying to penetrate through it, because latex is a dense material. It does take a lot of laser power, and it can eat a lot of your laser power away. But if you want a really good mask, I guess, then yeah, it's not going to hurt anything. Latex works fine with the laser. Yeah,
there are a couple of companies that sell a laserable or a laser-ready paint-on mask. The big issue with that is the consistency, right?
That's true.
If you have thin spots and thick spots, it's going to laser differently into your material, right? You're going to end up with deep spots and light spots in your material because
it transfers.
And latex is a material that requires a lot of power to get through.
Oh, yeah, exactly. So what does laser cut acrylic tend to why does laser cut acrylic tend to develop cracks? I think that was basically answered with the alcohol. Stay away from it's going to be caused by your cleaners. Nothing else will cause that. Extensive testing, stay away from it. Use the hexane or the heptane-based cleaners. Stay away from the alcohol-based paints. That's why it develops cracks. Great question today, and a very common question. And this is why we have a course just on acrylic, because there's so many questions.
Yeah. Laser cutting of acrylics, you're putting so much heat into such a small area, you're actually putting thermal stress into the material. And alcohol specifically, but any kind of solvents, acetone, there's a whole list of them, gasoline. There's a bunch of things that have solvents in them that what they do is they release those thermal stresses by fracturing the material. It's called crazing. And so that's if you're getting that effect, it means something you're using is causing it. I actually had a customer a couple of years ago who goes through literally hundreds of sheets of material a month, and all of a sudden they started having problem with crazing, and they swore up and down they weren't doing anything different with their process. They weren't using a different paint. They weren't doing anything. And it turned out that they had run out of the orange-based cleaner that they were using. And so instead of ordering it from the usual supplier, somebody ran to the hardware store and got the same thing. And that new orange-based cleaner had a solvent in it. And
something changed on the solvent.
As soon as they changed back to the regular material, their problem went, or the regular cleaner, their material went away. So
yeah, always suspect your cleaner.
Yeah, that's what's causing your cracks.
Thank you. Very interesting presentation. Be helpful tips and tricks. Thank you. Happy to have you here.
Mm-hmm.
All right. All finished. Perfect. Alan, thank you so much for joining me. Thank you, everyone, for joining me. It's been fun. And next month, we have our launch of our Ruby 2.0 software. So definitely stay tuned. Sign up for that. We'll be covering all the new exciting, fun differences of how you can benefit by our new Ruby software next third Thursday in the month of July. So we'll see you all there. Thank you so much for joining.